In this lesson, we are now looking at the characteristics of our exponential functions, but also looking at logarithm functions. So looking at the relationship, and we'll talk about, and we've graphed 2 to the x. So if you were to graph this on your own and then fill in the table, you would see that the values here were here, so to fill in. Now, if I wanted to graph log base 2 of x, you would notice here, and if you were to keep the two together, it should look something like this. So notice how it's almost like if I were to draw here the line y is equal to x, the graphs are flipped. It is a reflection. So like for example here, the point -2, the first point here, -2 and 0.25, which is here, has been completely flipped. So now it's at 0.25, but and -2. Same thing here. I'm now at -1, 0.5. So then flipped completely is now at 0.5, -1. So notice how the coordinates got switched. This is the whole idea of inverses, everything getting flipped. My x and my y values, now my y values became my x's. So again, it's all about this idea of inverses and flipping. So keeping that in mind, and that's why we're looking at both of these types of graphs today in this lesson. So like here in example 1, we're looking at the graph y is equal to 3 to the x. So here's an exponential. Now, we're going to talk today too about an asymptote. This is like an invisible line here that the graph approaches but never reaches. So notice how here it flattens. So this is my asymptote. Our graph here keeps going up but does not keep going down. It approaches but never reaches our asymptote, which is here at, so we'll say at y is equal to 0. Now we're going to use this asymptote to define and identify our domain and range. Now notice the domain, our graph is constantly going left and constantly going right. It's getting wider and wider. So this is all reals, or -infinity to infinity. Now, the range though is different because our graph is constantly going up, but is it constantly going down? No, because it's not going past what value? The y value of 0. So all of our y values, and because it's above, is greater than 0, or again, starting at 0 and going up to infinity. Now we're not including, not putting a bracket, right? Because it never reaches 0. So then our end behavior, as x's are going to the right? Because we're constantly going to infinity. So as x's are going to infinity, our graph is going up to infinity. But now as we're going to the negative, right, as we're going left, is our graph going down to negative infinity? No, it is approaching the asymptote of 0. So notice that asymptote does come into play here. So go ahead and pause the video and try this. You try for this exponential on your own. And here we go. So again, notice here we're constantly going left and right with this exponential and approaching, again, y is equal to 0. So again, the domain is all reals, -infinity to infinity. The range is above, so it's going greater than, but y's are still greater than 0, or 0 to infinity. Then here, as we're going to the right, as we're approaching infinity, now is our graph going down to negative infinity? No. Now notice this side of the graph is approaching the asymptote of 0. Now as we're going to the left, as we're going here to negative infinity, our graph is going up to infinity. Now here in our next example, here's another exponential, but a little different because the asymptote's not at 0. Notice how it got shifted up 4. So here, our asymptote is flattening here at y is equal to 4. Now, even though it gets shift up and down, the domain is constantly left and right, so the domain is all reals, or negative infinity to infinity. Now notice though, the y values got cut up, right? And it's below the asymptote, so less than, not less than or equal to, sorry, just strictly less than 4. Or starting now below, right, negative infinity up to 4. Now, our right side again, as we're going to the right, to infinity, our end is approaching the asymptote here at 4. Now, as we're going to the left, we're going negative infinity. Now, notice our end is going down to negative infinity. Pause the video now and try this exponential on your own. And here we go. So you should have seen that here's our asymptote at y is equal to negative 3. Again, our graph constantly going left and right, so the domain is all reals. And the range is cut off. It's constantly going up, but not down. So y values are above our asymptote at negative 3. So again, negative 3 to infinity because it's above. And as we're going to the right to infinity, our graph is going up to infinity. Then on the left side, as x's are going to the left to negative infinity, notice our graph is not going down, right? It's approaching the asymptote at negative 3. Now here's our log. Notice a little different. Our log, now everything is going to be flipped. So notice how all of our exponentials had a horizontal asymptote. So guess what our log is going to have? Vertical. So notice our vertical asymptote, and it's not y equals, now it's x equals 0. Also, going back to our exponential, what was always all reals? The domain. So guess what's going to be all reals? The range. Notice how our graph is constantly going up and down, no cutoff. So now the range is all reals, negative infinity to infinity. So that means our domain, our x values are starting at 0. So x's are going to the right, so greater than 0. So again, 0, not including it, so parentheses to infinity. So go ahead and pause the video and try this. You try on your own. And here we go. So again, your asymptote vertical, x values are starting here at 0, greater than 0. Oh, sorry, our asymptote, sorry, my fault. X equal to 0. That means, again, our graph is constantly going up and down, no cutoff, right? So the range is all reals. However, the domain, the x values are starting at 0 and again going to the right, so greater than 0. Now here, as x's, so now here, we're going to look at the end behavior. I'm going to go back to the example. So now notice, as we're going to the right to infinity, our graph is going up slowly but surely, because remember, right, it's not being cut off to infinity. Now, notice and keep in mind the domain is what was cut off, right? So is our graph constantly going to negative infinity? No. So now on the left side, our graph, our x values are approaching 0, the asymptote. Now what's happening to our end? It is going down to negative infinity. So now notice the x values, right? Our domain is cut off. So here the x values are also here cut off. Go ahead and pause the video and try this end behavior on your own. And here we go. So notice, are we constantly going to the right? Yes. So as we're approaching infinity, our graph is going down to negative infinity. Now, are the x's going to negative infinity? No. They never approach and we get closer to 0. But the end is going up to infinity. So now looking here again at our log. So let's see. Remember, right, what type of asymptote do we have now? Vertical. This is our x's equal to 3. That is our asymptote. That means what is all reals? The range, because it's constantly going up and down. So that means the domain the x values are, notice how it's to the left, so less than 3. So again, negative infinity to 3 here, because we're going left, less than. Then the right side. So is our graph going to infinity? No. Our x values are approaching 3. Now what is our n doing? Going down to negative infinity. Now is our graph going to the left? Yes. So as x are approaching negative infinity, our end is going up to infinity. Go ahead and pause the video and try this. You try now on your own with our log. And here we go. So again, our vertical asymptote, x is equal to 2. So again, our range is all reals because the domain x values are going to the right, so greater than 2. Then the end behavior. We are going constantly to the right, so as x is approaching infinity, our graph is going up to infinity. However, we're not going to negative infinity. Our x values on the left are approaching 2. As we're doing that, our graph is decreasing, going down to negative infinity. So now here we go, our last couple. We're going back to an exponential, but again, just focusing on like with a base e here. But same thing, an exponential, which means what type of asymptote do we have? Horizontal, meaning y is equal to -1. So now what was all reals? The domain, because our graph is constantly going left and right. Near negative infinity to infinity. That means our y values, right? Our y's got cut off. Notice how starting at -1 and going below, so less than -1. So again, negative infinity to -1, both parentheses because we're not including. Now here, as we're going to the right to infinity, our graph is going down to negative infinity. As we're going to the left to negative infinity, are we constantly going up? No. The y values are approaching the asymptote -1. Again, go ahead and pause the video and try this exponential on your own. And here we go. So again, we have an exponential. So we have the horizontal at y is equal to 2, which means again, constantly going left and right. So the domain is all reals because our y values are now starting at 2. Notice how graph is above greater than 2. So again, 2 to infinity. Now, as we're going to the right to infinity, our graph is going up to infinity. As we're going to the left here to negative infinity, our graph is not going down, right? It's approaching the asymptote, the y values at 2. Then last, we're going to end here with our log. So this is a natural log. So here again, this being a log, what type of asymptote do we have? Vertical here at x is equal to 1. So again, we're now constantly going up and down. So the range is now all reals, negative infinity to infinity. Because the domain is being cut off here, right? Our asymptote, x values are starting at 1 and going to the right, so greater than. That means here our end behavior will also be cut off. As we're going to the right, so we are constantly going to the right, our graph is going up to infinity. Now, are we constantly going to the left? No, right? As our x values are approaching the asymptote at 1, our graph is going down to negative infinity. Go ahead and pause the video now and try this. You try on your own. And here we go. So here again for our log, we have a vertical asymptote at x is equal to -4, which means what is all reals? Our range, right? Because our graph is constantly going up and down. The domain x values are cut off because our graph is never approaching -4 and going left here, so less than -4. Here, negative infinity to -4 here. Again, not including, so both parentheses. So is our graph constantly going to the right? No. our graph is approaching -4. So as the x value is approaching -4, our graph is going up to infinity. Now, are we going to negative infinity? Yes. So as x's are approaching negative infinity, our graph is going down to negative infinity.